So we were talking about the acids and bases, and we went into very like more theoretical, concept-wise stuff also last week. That's about the theories of acids and bases. Before that, whatever we have learned, even in school, we have learned so far more practical stuff, right? More general stuff. And last week we went to some theories that define why these substances are acids and bases. Right? We learned two theories. What are those two theories? By name, you don't have to remember by name, but by name, how do you call them? මතක් ගන්න නම් දෙක. එකක් මොකද්ද? අපුතුල බෝඩ් එකේ තියෙනවා. බෝඩ් එක බලන්න උත්තර දෙන්න. Promissory theory. Another one, Arrhenius theory, right? So, which one is more like friendly for us, friendly to us? The one that we are familiar with, which theory? We have been like doing that since the start of this lesson. Which theory we have been working with? Arrhenius theory is the Bronson law. Which one was like familiar from the beginning? Huh? It's the last few. Right? Right? මොන theory එකද අපිට වැඩිපුරම මේ close? It was Arrhenius theory. In the Arrhenius theory, they are dealing with aqueous solutions. Right? Aqueous solutions, the acids give H plus ions, alkalis give OH minus ions. That's what we have been learning, except for ammonia and O2 minus that we discussed. Right? It's the usual H plus and OH minus. Bronson-Lowry theory is the one which is kind of new. It says the transfer of proton. In Bronson-Lowry, sometimes unexpectedly, some substances we can define as acids. Some substances we can define as bases. For example, water. Water with HCl, you can see it has accepted the proton. Therefore, it is a base. And ammonia has accepted the proton from water. So ammonia is the base, water is the acid. That was the last thing we did. So then, according to this theory, some like tricky things can be what? Explained. Right? Or, and then that was the last thing we did. So then we stepped into part of this lesson, which is very critical, called salts. Right? Salts, this, right? But again, it's here. And such an important part because today we will be talking about salt preparation. Salt preparation in the sense, how do you make a salt? Starting from acid and some other substance. Right? That's our main objective of today's lesson. And it will be very important part of your syllabus as well. So to make sure that you are kind of familiar with the salts, so let's quickly completely stable about salt formation. But I will do on and off like few of them for you to get an idea. For example, the best thing to understand the salt formation, what ions that the acid and the alkali would dissociate. That will give you more confidence to understand. For example, sodium hydroxide, you have sodium plus and hydroxide. And in nitric acid, let me take nitric acid into account. H plus and what? NO3 minus. These are the two ions. Then if you write a reaction between sodium hydroxide and nitric acid, it should be what? Sodium nitrate. So be careful with the valencies, right? And ethanoic acid, I'll take three examples which are different from each other. Ethanoic acid, the ions are ethanoate ion and H plus ion, right? So then I'll write ethanoate ion. This is your ethanoate ion, CH3, C double O minus, and this is your H plus. So if ethanoic acid reacts with, suppose calcium hydroxide, so this is a little tricky. Calcium hydroxide, you have Ca2 plus and OH minus, two OH minus are there, but I'm not considering that. Since calcium is 2 plus, calcium ethanoate can be written like this: CH3, COO minus. Now you don't write the charge when you write the salt. So you put a bracket and put twice. Why? Calcium is 2 plus, ethanoate is minus 1. Therefore, you have to solve the valencies. Can you understand? Right? Formula of the salt. Another example, if I take sulfurous acid, it breaks as 2H plus and sulfite ions, right? And let me take aluminium hydroxide into account, Al3 plus and hydroxide ions, right? You have three hydroxide ions, but just right. So aluminium 3 plus and sulfite is 2 minus, therefore you have to solve the valencies. You can write Al2 SO3 thrice. Likewise, you need to know the ions. Is that clear? So the first task of the today's lesson, complete this table. We'll see. Now, don't do the ammonia one. Ammonia one is little tricky, right? Ammonia one, I'll explain. Sorry about it, I couldn't tell you. Don't do the ammonia one, fill the rest. Huh? Ammonia? So this must have been very difficult at the beginning, especially the formula. But if you are careful and you are working by this time, you should be like feeling. ඒක දිහා බලනවා අනිත් අයව ටීවී එකට මයන්ස් වලට බ්‍රේක් කරගන්න ඕනේ. ඒක තමයි වැඩි කරන්න පුළුවන්. ඒකෙදි වීඩියෝ එක කියනවා මොකද ඒකේ අපෝ දේවා එච්චර ගොඩ ගොඩක් පිළිතුරු. ඒකෙදි අපෝ හරියට කියන වීඩියෝ එකකට මෙහෙම කියන්නේ වගේ මයින්ඩ් එකේ ටීවී එකේ minus of the name of paper or we go to the university. Yes, I will look it. So, I will put it. So, the idea they are seeing you for the charge of what is that? Minus 2 is then when you after it comes to the hydrogen and backup can carbon into charge with you. Just I only I mean, opening see the number can see what update. You what is the operating There's the vacancy clear. So board is like going the vacancy for one place. You are all right. Okay. Now let's see a very interesting one. Describe how you would decide acidity of salts by considering the parental acid and base. Now, are salts acidic or base? Acids are acidic. Bases are base. What about salts? Huh? Those are acidic. They salts acidic. Can get the chemical lulu acidic. Common salt acidic. What is your opinion? Also, what do you think? Yeah? Basic. Yeah? Also, common sense monarchy can neutral. Salts are neutral. They will be because salts are made from neutralization reaction. Acid and base. They will be healthy. Salts are neutral. The sodium chloride වතුරට දැම්මම pH එක අපි කියන්නේ නෑනේ pH low 6 කියලා. නේ? අපි පොඩි කාලේ ඉඳන් දන්න දේත් ඕගොල්ලෝ දන්නේ නැති එකයි දුකම. පොඩි කාලේ ඉඳන් grade 7 8 වලින් ඉගෙන ගත්ත පොඩි දෙයක් තියෙන්න එපයි. නේද? ඒකද අපි කියනවා salts are usually what? Neutral. But the truth is not always the salts are neutral. Right? They can be acidic in nature or basic in nature. Right? අපි ඉගෙන ගන්න එක කලින් දැනගෙන ඉගෙන ගන්නවට කමන්නේ නැහැ. හරි. අපි එක්සැම්පල් එකක් ඉගෙන ගමු. අපි හංසනාගේ හරිද හැමදෙස්සම හංසනාවනේ හවුවෙන්නේ. වැඩේට අපි දුලේ ඉන්නවා ගමු. දුලේ ඉන්නවා. මම ඇහුවොත් දුලෙන් looks like looks more like your father or more like your mother from your appearance. පොඩි කාලේ තාත්තා වගේමයි කියලා අම්මා වගේ තාත්තගේ නාමයි කියලා. What do you think? You look more like your mother. Hey, yeah. අම්මගෙන් එනවා half the genes. තාත්තගෙන් එනවා half the genes. You know from biology. Right? හැබැයි he looks more like his mother. ඒ මොකද? අම්මිගේ genes තමයි appearance එකට වැඩිපුර මොනවා වෙලා තියෙන්නේ? Express වෙලා තියෙන්නේ. නේ? What about you? You don't know what people say. That means you are in the middle, exactly middle. Is that? Neither closer to father mother's genes. That means both are expressed equally. එතකොට වෙනම look එකක් තියෙනවා. What about you? Huh? In the middle. Yeah, all right. Right? Huh? What about you? Look like more like your mother, right? Okay. ආගේ ජීන්ස් එක වැඩිපුරම එක්ස්ප්‍රස් වෙලා තියෙනවා. ඒ සෝල්ස් උත් එහෙම තමයි. සෝල්ස් වල ජීන්ස් කතාවක් නැහැ. හරිද? Souls වල whether they are acidic or basic depend on their parental acid and base. Two acid and base react to give a salt. No? You get it? I'll show you how to apply that. Before that, one thing I couldn't tell you. We didn't feel the ammonia one, right? Ammonia one, and also I didn't include the answers for this, right? Among the answers to talk about the check the answers. Correct, correct. Mistake, you know, Right. Now let me explain how the ammonium salts are written. Right? Don't write anything else other than checking your answers. මේවා එහෙම ලියවන්න කියවන්න එපා CH3 cook CH3 දිනවල බෑ බෑ වගේ තමයි තියෙන්නේ. Know the symbols and the names. Now when you write the formula of salts of ammonia, right? So you see first of all ammonia and HCl, right? So then you decide the salt's name. The salt's name, ammonia and hydrochloric acid, you call it ammonium chloride. Ammonia and nitric, ammonium nitrate. It's not ammonia nitrate, it's what? Ammonium nitrate, right? And then ammonium chloride. So, then you remember ammonium ion, we learned even in the formula lesson. Ammonium ion's valence is 1, NH4 plus, Cl minus. Then you swap it. So you get NH4Cl, right? So follow the name. So ammonia and sulfuric ammonium sulfate. Ammonium is +1, sulfate is -2. You write ammonium twice, sulfate 1. Ammonium methanoate. Here I have written ethanoate first, doesn't matter either way, right? Ammonium carbonate, ammonium sulfide. Is that clear to you? Right? Ammonium source energy clearly, right? Huh? Okay, you try that also. You complete this also. Take a step. Ethanoate එක කලින් ගියනකොට පස්සේ දෙන්න. Ammonium එක complete නම් ඊට පස්සේ clear you maybe what position related. Here the ammonium source. Right. We can check ammonium nitrate. All right. Now I'm going to describe how you decide whether a salt is whether salt is neutral or acidic or basic. Right? Until this point, we knew salt is neutral. Okay. Now what I said, parental acid base case, okay? Right? Then, he said he looked like mother. Right? Again, mother's genes are strong. Appearance expression. Right? It'll make one. For this, first of all, suppose now we are going to find out whether sodium chloride is acidic or basic or neutral. Right? What you do, you try to mentally or in a rough paper see whether from which alkali sodium came. Sodium ion again, what alkali again? Alkali is the one with the hydroxide. Sodium ion is coming from what alkali? It was in the table. Come on. Sodium ion is coming from which alkali? Huh? Sodium ion going the hydroxide. So, compound එක නම කියන්න fully. Sodium hydroxide. What අගාර decide කරන්න ඕනේ මෙයාගේ base එක කවුද? Chloride ion එකෙන් කාගෙන්ද? Hydrochloric acid, right? So then you decide, right. Now, what is sodium hydroxide? That you don't know. That I have to give you, right? Sodium hydroxide is known as a strong base. It is a strong base, right? In this list, ammonia is a weak base. Even aluminium hydroxide, right? These are usually strong bases. These are strong bases. All group 1s are strong bases and calcium hydroxide and barium hydroxide too. Magnesium hydroxide is a weak base, right? And HCl, nitric, sulfuric, these three are strong acids. They are strong acids. They are strong acids. And these guys are weak acids. These guys are weak acids. Right. So, and this is a strong base and this is a strong acid. Then ඔයාට පුළුවන් decide කරන්න sodium chloride මොකක්ද කියලා ලියන්න පහකට. Type දෙන්නද. What is sodium chloride? Neutral. Right. Both are coming from strong acid, strong base. So it is neutral, neutral salt. That's the story. Hi. So we have example. Let's take an example like ammonium chloride. Ammonium chloride. Ammonium chloride. So ammonium chloride. Ammonium is coming from what? What is the ammonia. What is ammonia? It's a weak base. Chlorine coming from hydrochloric acid. Yeah, hydrochloric acid. Hydrochloric acid. Take a strong acid. Then weak base and strong acid. What properties should be remaining? Target properties at the end nodes. Acidic, acidic is wrong. Therefore, ammonium chloride is a what kind of an salt? It's an acidic salt. ඔයා අහලා තියෙනවද fertilizer soil වලට ගොඩක් දැම්මම like after using fertilizer long term the soil gets acidic. That's because your fertilizers are usually ammonium salts. They're acidic. So when you use it long time in agriculture, the soil gets what? Acidic and soil become infertile. Right? එනේ base එකක් දාලා ආපහු neutralize කරන්න ඕනේ මේ cultivate කරන්න ආපහු. Right? We'll be facing those kind of questions in future. තේරුණාද? මේක දැන් එතකොට මේක acidic salt එකක් ඉතින් තේරෙනවද? Sure? Right. Another one. Let's say sodium carbonate. Sodium carbonate. Sodium carbonate. Our sodium is coming from මොකක්ද එයාගේ base එක? නෑ මොකක්ද base එක කියන්නේ නගුරු. Sodium hydroxide. Strong base or weak base? Strong base. Weak base? Sodium is strong. Right? Carbonate is coming from what acid? මොකක්ද acid එක? Carbonic acid. මොකක්ද formula එක? H2CO3. ඒක පාඩම් කරන්න ඕනේ දැන් ඕගොල්ලෝ. අනේ දරුවෝ මේ මම කොච්චර මෙතන කියලා දුන්නත් ඔයා මේ බේසික් ෆෝමියුලා පාඩම් කරන්නේ නැත්නම් මේක කරන්න බෑ. පස්සේ ඔයගොල්ලෝ පේරන්ට්ස් හරිය අයියෝ කියලා දුන්නේ කිසිම දෙයක් තේරෙන්නේ නැහැ කියලා. ඕක තමයි that's why you betray your teachers. right? පේරන්ට්ස් ලාගේ බැලුම් අහන එක නතරයි. right? ඕගොල්ලෝ මේ බේසික් ෆෝමියුලා පාඩම් කරන්නේ නැත්නම් කරන්න බෑ. I gave you a list of acids, right? ඒවා පාඩම් කරන්නේ නැත්නම් කරන්න බෑ. right? Okay. So then what's carbonic? It's a weak acid. right? Iron මේක මොකක්ද salt එක? Acidic the basic. It's a acidic or basic. Basic. That's why we say carbonates are not bases. They are basic salts. Carbonates are not bases. They are basic salts. That's why they react with what? Acids. If you want a reaction like acids with carbonates, then there another. This is how you decide your salts acidic or basic nature. Right? Before that, why not we quickly write that point where strong acid and strong base will form neutral salt. ඔයාම ලියන්න ඕනේ statements හතර. හරිද? And also මේක කෙලින්ම copy කරගන්න තමයි. Copy කරලා I want you to quickly look into your table and figure out some acidic salts and basic salts and neutral salts. right? ඔගේ table එකේ දැන් salts ගොඩාක් ඇන්දනේ. නේ? ඒවල බලන්න acidic salts මොනවාද neutral salts. Right enough. So now few examples. Let's have a look at the table. So sodium chloride, neutral. Hey, strong acid, strong base. Potassium chloride, neutral. Why? Strong base, strong acid. What about calcium chloride? It's almost neutral. It's slightly acidic because calcium hydroxide is not a very strong base. What about aluminium chloride? Acidic. Why? It's coming from a weak base and a strong acid. But then acid, salt, these things must come to your head. What acid and what base made the salt? It is not essentially the salt is made from that too, but that those are the parent acid and base, right? And then you can tell whether it's acidic or basic, right? හරියන අපි දැන් තම්දාන හැම එක්කෙනාගෙම කාලා බලමුද මේ try එකක් දාලා පුළුවන්ද කියලා මයින්ඩ් එකෙන් ඕක ඩිසයිඩ් කරන්න. හංසනාගෙන් පටන් ගමු. කියන්න බලන්න potassium sulfate. Potassium sulfate. Neutral. Why? මොකද බේස් එක? Sulfate එක කාගෙන්ද? Sulfuric acid. ඒක අන්න එහෙම කියන්න පුළුවන් එන්න. Smart girl නේ. පිස්සු නතර හිටියේ. Potassium carbonate. Basic. Potassium carbonate. Why? Why? Potassium is strong.
Potassium is strongest, right?
Huh?
Potassium hydroxide.
Strong base there. Carbonic acid. Is that? Weak acid. Good. Where again one ammonium sulfate. Why? Good. You aluminium sulfate. Basic. Why? Acidic. Good. And you tell me sodium ethanoate. Sodium ethanoate. Basic.
Basic.
Why?
Strong base, weak acid.
Strong base. Weak acid. Right. මොකද්ද strong base එක මොකද්ද weak acid එක? Weak acid is මොකද යාගේ නම? ෆෝමියුලා එක හරි කියන්නකො දන්නේ නැත්නම්. CH3 කූච්ද? මොකක්ද?
CH3.
එතනොයික් ඇසිඩ් නේ මන් දන්නේ පාඩම් කරන්නේ නැද්ද ගෙවල් වල ගිහින් කොන්නවද මන් දන්නේ. ammonium ethanoate. කියන්නේ කමාරු එකක්. Neutral, very good. Smart girl. Okay. Why? Very good, very good. Barium sulfate. Why? Why? Yeah, no, මොකද ඇසිඩ් එක මොකද බේස් එක කියලා කියන්නේ.
Sulfuric acid and barium hydroxide. Yes, base.
Potassium nitrate. Huh? Neutral. Why? How? What do you call the alkali? Yeah. නම් මොකක්ද කියන්නේ? potassium. මෙච්චර වෙලා දැන් මේ ළමයි කියන්නේ අනේ බේස් එකේ නම් මොකක්ද? potassium hydroxide. ඒක strong base. acid නෙමෙයි strong base. strong acid එක මොකක්ද? nitrate ආපු acid එක මොකක්ද? හරි nitrate ආවේ මොන acid එකෙන්ද? code එකේ තියෙනවා. nitric acid. Okay. Next one. Copper sulfate. නැති උනාට පුළුවන් වෙන්න ඕනේ කියන්නේ. I told you group 1 and those are only strong bases. Strong acid? I never said strong. I said acidic or basic or neutral. What is it?
Acidic acid.
Acidic. Okay, why?
Copper will be base.
Copper නෙමෙයි. Copper hydroxide.
Copper hydroxide.
Sulfate.
Sulfuric acid in it.
Okay. You. Lithium sulfide. Lithium sulfide. Lithium sulfide. Sorry? Acidic. Why? Lithium? නෙමෙයි lithium hydroxide. Strong base, huh? එතකොට acidic ද එතකොට? Base එකනේ strong. ඒකද. Nisini, Prute, you are the new one for the class? You joined today?
No, sir, I was there.
ඒක තමයි. හරි. කලුත් බබන්නේ නෝවි. නිසිනි කියන්න බලන්න මේ barium chloride.
Neutral,
Why?
because barium is a strong base and
barium නෙමෙයි strong base එක.
barium hydroxide is
Ah.
a strong, and HCl is a strong acid.
නිසිනි කියන්නේ මෙතන ඉන්න. ඔයා මේ online ඉන්නකොට හොඳට කතා කරනවානේ. ක්ලාස් එකේ ඉන්නකොට කතා කරන්නේ නැත්තේ. potassium carbonate. Basic, why? Good. Barium nitrate.
Because barium it is a heat.
Barium nitrate?
And
Barium nitrate තමයි so is a
neutral.
කවුද neutral?
Barium hydroxide is a strong alkali and nitric acid is a strong acid.
Yeah, therefore දැන් තේරුණා කතා. Very nice. මේක part එකක් හරි. Right? Now we go for මේ salt ගැන තමයි අද කතා කරන්න වැඩි. Now, is it necessary for salt to be producing acid-base reaction? Acid-base reaction වලින් විතරද salt හැදෙන්නේ? කතා කරන්නේ නෑ. ඇයි acid carbonate reaction? metal acid reaction. But properties of salts are considered. I make a feel කරන්න ගෙදර. මෙන්න එනවා the topic of the day. Topic of the day. What is that? Solubility of salts. Extremely important topic. අද මේ ටික පාඩම් කරලා තමයි ගෙදර යන්නේ. Right? Next day then we can complete. Next day නෙමෙයි අදම complete කරන preparation of salts අද එකක් කරන්න ඕනේ. Guys, now we had a problem of putting those physical states මතකද? Make a aqueous, make a solid. Now, if it is a metal, you don't have any problem. It's a solid. It's an acid, you don't have a problem. It's aqueous. Right? It's aqueous. It's aqueous, you know. But if it is an ionic compound, okay, a gas like carbon dioxide, no problem. But if it is an ionic compound, some ionic compounds are soluble in water, some ionic compounds are not soluble in water. That's why you did precipitation in the qualitative analysis. Precipitate උනේ ඇයි? ඒගොල්ලෝ soluble නැති නිසා. Therefore, we need to know from the compounds that we had to encounter in our syllabus. How do we know this? Is it possible? No. Any compound which is a group 1 compound. Group 1 compound compound together. You have sodium, lithium, potassium. Is there? Those compounds are, I mean, they are solids at room temperature. Ionic, pure form is solid. Pure form is solid. The ionic compound. But when you drop that into water, they will most probably dissolve pretty well. They are soluble salts. Right? Read the first read the first rule. All group 1 compounds are soluble in water. Nisini read karan. Nisini read karan.
All group 1 compounds are soluble in water.
You're supposed to put the camera. Right. Second rule. Then, okay. What about the first rule? Is it a black and white rule or not? Is it a black and white rule or not? So black and white rule. What is black and white things? So either black or white, no gray. So he says all. That's a black and white rule. Ekko make a black, ekko make a white. එච්චරයි. එහෙම කතාවක් නේ. If it is group 1, soluble. Not, may not. So අනිත් ඒවා ගැන කියන්න දන්නේ නැහැ. Sure group 1 is soluble. The black and white rule. You get it? Right. Next. All nitrates, that means salts end with nitrates, they are anions. Hydrogen carbonates. Salts end with carbonate, hydrogen carbonate, not carbonates, hydrogen carbonates, HCO3. All ammonium salts. If you hear ammonium, starting from ammonia, or in the middle ammonium, all these compounds are soluble. Example, calcium nitrate, iron nitrate, calcium hydrogen carbonate, ammonium chloride, ammonium nitrate. කොහෙන් හරි nitrate හරි ammonium හරි hydrogen carbonate හරි ගෑවුනොත් soluble. But calcium we don't know, iron we don't know. Doesn't matter. Nitrate is not insoluble. If I ask nickel nitrate, බයවල දාගන්න එපා. Nickel we didn't study. අර reactive. Over there is the key. Ability will listen. Nickel nitrate, nickel done there, nitrate. Nitrates are soluble. Nickel the soluble. You get it? So we are going to decide. In the first two, you can see we have to write 6 of them. I just explained 2 of them. എന്നിട്ട് ബ്രെയിനിനെ കൂടെ ജാഗരണ ഗവൺമെന്റ് Done? Okay, rule number 3. Read. Okay, except for silver chloride, silver chloride, silver bromide, silver iodide, lead chloride, lead bromide, lead iodide. Now, they look like a lot. They are not a lot. Like it's a silver halides and lead halides. They are not soluble. Okay, now look at this. You didn't read the second statement loud, no? Second loud given, you have to read loud. You need to hear your own voice to remember things. Second read kar. Read kar. No, wait. 1, 2, 3. All. Good. Third one. Halides, chlorides, bromides, iodides are soluble except for silver and lead halides. Example, now is it a black and white rule? Is it a black and white rule? No. Did they say all halides? No. Right? Halides are usually soluble. Shape is soluble. But there are some halides which are not soluble. True, no, we precipitate a silver chloride, silver bromide, silver iodide as white, cream, yellow precipitates. Right? As same as like lead salts. Right? So if you see any kind of a salt like magnesium chloride, iron 2 chloride, aluminium, zinc chloride, zirconium bromide, whatever, doesn't matter. According to this rule, halides are usually soluble, except for those. But if you hear like silver bromide, okay, halide, but exception. පග්ගල මතක් වෙන්න ඕනේ ඒකද මොකද්ද මේ insoluble. නිසිනි කියවන්න බලන්න third එක.
Halide, chloride, bromide, and iodides are soluble except for
Silver and lead halides. That's how you say in short. All right. Now you read rule number 4. Read. Sulfates are lead sulfate. ASE තව පොඩි කචල් දෙකකුත් තියෙනවා කවුද? Calcium sulfate is slightly soluble. That means sometimes calcium sulfate is a solution. If too much of calcium sulfate is there, it's a precipitate. Right? So then the rule number 4, sulfates are soluble except for what? Lead sulfate and barium sulfate. But how you can negative sulfates are soluble except for barium sulfate and lead sulfate. That two are not soluble. You can't dissolve them, and if they form in a reaction, they will be precipitates. Understood? Now you write those two rules. So from 1 to 4, they are more towards soluble stuff, right? Aren't they? They are more towards soluble stuff. Right. Now we'll come to the last two rules. Right? The rule number 5. You need more time? Okay. Rule number 5. Now things are becoming soluble or insoluble. Rule 5. Carbonates are insoluble. But there are some rules on top. Those are top priority. Even the carbonates are insoluble. Your group 1 and ammonium carbonate should be what? Soluble. Those are the top priority rules. You get it? Get what again? Normal there, I am saying iron carbonate. Soluble or insoluble? Huh? Iron carbonate? One rule, carbonates are insoluble except for group 1 and ammonium carbonate. Right? Okay. Carbonates are insoluble. Iron carbonate, iron 2 carbonate, huh? Calcium carbonate, calcium carbonate. Again, by the way, carbonate. Soluble, insoluble. Barium carbonate, listening, barium carbonate. Barium carbonate.
Soluble.
Soluble. Rule එක බලන්නකො පුතේ. Carbonates are insoluble. So who are the only soluble carbonates? Group 1 and ammonium. Is barium group 1 carbonate? No, it's some other carbonate, so insoluble. Copper carbonate, copper 2 carbonate. Insoluble. Okay. Easy. Right? Lithium carbonate. Soluble. Like that. Historically, they are group 1 and soluble. Carbonates කතාවකටක් නෑ. Last one. ඒ කිව්වේ නේද? හයියෙන් කියන්න බෑ. Rule number 5. Okay, last one is not a salt, it's hydroxide. But that also you need to know because hydroxide we learn metal hydroxides are bases, soluble ones are alkalis, the others are noble bases. So then you need to know what are soluble ones and what are not soluble ones. So easy. Usually hydroxides are insoluble, except for group 1 ammonium, barium hydroxide and calcium hydroxide. Slightly soluble. Calcium sulfate and calcium hydroxide, then now slightly soluble. I'll tell you where it will be important. Just for the moment, you remember that. Read the last second. Loud hydroxides are insoluble except for group 1, except for group 1 hydroxide, ammonium hydroxide, barium hydroxide, and calcium hydroxide is slightly soluble. Okay, these are the rules now. 6 rules you need to study now and go home after discussing things. Okay, I'll give you 5 minutes to study. Madhi? 5 Madhi? 5 minutes. Hello? Oh, yeah, really? So write down and study. I'll give you 5 minutes. 5 minutes to study because already you can remember stuff. You can help your brain to remember things. Huh? May the rules here, all together. See, 2 of them are top 2 black and white soluble ones. Last 2 almost about the insoluble stuff. Middle 2 they are about soluble and you have some insoluble ones also. And they are going to help. Okay. right? एना भी बालो check करो. Close your books. Ini screen में का तो off कर गए. मैं make close. नहीं कैमरा का नहीं मैं off कर गए कि screen नहीं. Right. Again, balan kagindahan. How many of you can remember all 6 straight away? Bro, at least you can. Yeah.
Barium sulfate and lead sulfate. Calcium sulfate is slightly soluble. And then carbonates. Carbonates are insoluble except for one carbonates and
හයක් තියෙනවනේ පහක් කිව්වා.
oxides are insoluble except for one oxides and ammonium and barium hydroxide. Barium hydroxide. Group one is soluble. Group one is soluble. Sulfate, nitrate, hydrogen carbonate, and ammonium are soluble. Bromide and halides are soluble except for silver, halides and halides. Sulfates are soluble except for barium sulfate and lead sulfate. Hydroxides are insoluble except for group one and barium hydroxide.
එකක් කිව්වේ නෑනේ. මොකක්ද කිව්වේ? Carbonates are insoluble. Boys again. Water නේ ඉතින් water කැලේ කියන්න ඕනේ නැහැ. Sorry.
Bromides and halides are soluble except for silver, lead, halides. Sulfates are soluble except for barium sulfate and lead sulfate. Calcium sulfate is soluble. Very good. Carbonates are insoluble except for group one compounds and ammonium. Hydroxide are insoluble except for group one and ammonium and barium hydroxide. Calcium hydroxide is also.
Yeah, so you have to remember those things. I'm not going to ask from everyone. The reason is I need to save time. Finish, then you kill yourself, right? But next day I'll be asking randomly the solubility rules. Anyway, if you can't remember them, you are in a deep trouble in the exam. Right? Okay. So now what next? It's about this table, right? In table we pass it. Right. Okay, so you do this table as a homework and bring, okay? Like you get everything again here. Now we go for the next lesson. What are we going to do? We are going to talk about preparing salts. What are we going to talk about? Preparing salt. Tell me, it's on the board as well. Day-to-day life example for preparing salt, which happens in very large scale. When you travel to Hambantota or Uttalam area, common sight. What is that? Huh? Salt. Saltons. Have you seen saltons?
Yeah, yes. Uh, there's like these, I can't remember much of them, they're really small. There's like these huge piles of salt and they goes in a bus like around it.
Yeah, but for that, how are they made? How are they made? They pump seawater into shallow tanks nearby the coastal region. You have like paddy fields. You have seen paddy fields where they are going to grow the crops. Likewise, they are like square type huge shallow tanks made of like normal ground. And they pump seawater into them and they let CO2 settle and evaporate water. Once evaporated, somewhat evaporated, they pump the rest, the concentrated seawater solution into another tank. Because in the first tank, some compounds get sedimented. And in the next tank, they evaporate further, they get more concentrated. And some other compounds get sedimented, insoluble ones. Finally, they put it, that remaining water, which contains sodium chloride. Seawater is mainly sodium chloride and water. Put in another shallow tank where sodium chloride is going to crystallize. You're not evaporating all the water. And they spray a little bit of crystals of sodium chloride already made. And on top of those crystals, the new crystals grow and produce huge crystals of sodium chloride in those shallow tanks. Then they shovel them and dry them in a normal conditions. Right? That's how we get those crystal salt. And then they send that into the factory. In the factory, they will be more purified and converted into salt powder. It's called table salt. Sorry. Yeah, table salt. It's called table salt. What we consume usually table salt. One of the last vacation, we just went to Anuradhapura and coming back. It just randomly we went into a salter and one person gave us a big bag of salt crystals. I'll show you at the end of the day. Right? And so there you go. Sodium chloride solution. We evaporate water. We take the seawater into shallow tanks and we evaporate from strong sun and the wind. And then we evaporate further. You get sodium chloride crystals and then pile them up and let them dry in the natural ways and purified natural ways. Sometimes the rain falls and some of them washed away and fall into the tanks. But anyway, a bit of purified salt is there, and they manufacture much better salt in the factories. You get the point? But sorry, in the laboratory, we are also going to prepare salts. Right? The difference laboratory preparation of salt and the preparation of salt in industry. We don't have in the industry, we don't have to react something to make the salt because you have salt already in the sea. You just have to separate them. But in the laboratory, if we want to prepare the salt, first thing you have is what? You need to carry out a reaction in order to prepare the salt. Chemically prepare the salt. Then you carry out what? Separational techniques finally you subject that salt into what? Purification, and you get the salt. That's our plan. So throughout this lesson, we learned reactions where salts are made. Okay? So in this lesson, you need to decide what method of what reaction should be used to prepare which salt. Is that clear? Now, what are the reactions that we have learned to prepare salts? Metal, non-metal reaction, that I didn't teach, but that's pretty simple, straightforward one. Sodium and chlorine, sodium chloride. But we don't do them in the laboratory because they are little what? Dangerous reaction. Metal and non-metal reactions reacting, they are usually two vigorous reactions. What are the reactions that we are familiar with now? What are the reactions we are familiar with? Metal, acid, salt, hydrogen. What are the other reactions we are familiar? Come on, metal, oxide and hydroxides of metals, we are bases. You get salt and water. Acid and, sorry, metal, wait, acid and base, salt and water, right? Acid and carbonates, you get what? Salt, carbon dioxide, water, right? A new one I'm introducing, the reactions of a base. When you react ammonium salt, you today learn they are acidic. When you react ammonium salt with base, they produce salt, ammonia, and water. So you should know basically these 5 reactions, especially these 3 reactions. Especially these 3 reactions to prepare the salts. Is that clear? First and 5, fifth one are not that much important, but you know 2 and 3, 2, 3, 4 are the ones that we practice a lot. Is that clear? But that is only to prepare soluble salt. Soluble salt එකක් හදන්න කිව්වොත් තමයි මේ reactions කරන්නේ. ඒක තමයි trick එක. හරි දැන් මම ඔයාලට කියනවා sodium chloride salt එක හදන්න. Right? So what are you going to do? You are going to use one of these 3 methods because your salt is what? Soluble. If the question asks you to prepare insoluble salt, we carry out a different type of reaction called precipitation, which we haven't yet done. Right? I'll be doing that most probably next week. Today we are talking about preparing soluble salts. There are 2 methods. We'll be watching some videos and understand, and you'll be having hands-on experience in coming week. Right? Okay. Right. So then let's put this summary again. So this is basically the summary. That what you need is salt, metal salt, and metal, non-metal. So these 5 reactions. Okay. Now I'll emphasize the fact that if you are to prepare soluble salt, you can choose any of those 4 reactions. This is for soluble salt. Soluble salt එකක් හදන්න කිව්වොත් මේ reactions වලින් එකක් තෝරගන්න. Is that clear? If they ask you to prepare insoluble salt, then you choose the reaction called precipitation, which we'll be learning about it next week. Insoluble salt. So that is a repair. Then after that, you have to crystallize. Your life is easy with insoluble salt. What you have to do? You have to do only what? Filtration. I filter කරනවා insoluble. Solid එකක් තියෙන. filter කරගත්තා. But if you have prepared soluble salt, you have to do what? Crystallization. Put it into an evaporating dish, evaporate some water, get the crystals produced. And however, finally, washing and drying important. Drying and you put this into, right? You can tap them between filter papers or tissue, filter paper, or you have a apparatus called desiccator. You have apparatus that you know desiccator. Desiccator. Right? Silica. At the bottom part, you have something called silica. And you keep your crystals over here, close it with the lid. Silica will absorb, dry the crystals. Is that clear? So this is the outline of what you're going to do. Okay? Let's go. Make a precipitation reaction given as a top one. Right? So note so they write it accordingly. 1, 2, so you will go on till 5. Okay. Write it accordingly. Don't just blindly. If I don't, you want to put, what's the names? Places, building. Where you make that. अभी अगर याद हो रहा है इस तो लूप के लोग हम लोग के पास पड़ा हो मानवीय के लोग Alright. Let's do that. Done? All right. Now we are going to watch how to prepare the salt like copper sulfate. Let me check whether the sound's working properly.
So in this video today, we
Not bad.
in this video today,
We'll watch how to prepare copper sulfate.
we are going to look at how to prepare a dry sample of a salt. A salt is made by the neutralization of an acid with a base. And the base we're going to use today is copper oxide, the acid, sulfuric acid. So we will be making copper sulfate. So the first thing we need to do is take a measured amount of our sulfuric acid. And you'll notice I'm wearing goggles because I don't want to get the acid in my eye. This is quite strong, so I have to be quite careful. So just using a measuring cylinder, I'm carefully going to measure out 40 centimetres cubed of my sulfuric acid. Getting that, makes good noise. And I'm going to pour that into a beaker. Now, to make the reaction go a little bit.
Listen. After watching this, you have to write this stepwise. හරිද? ලියන්න ඕන. කොහේ හරි කමක් නැහැ. ඔයාලට pencil එකෙන් පොඩ්ඩක් sketch කරගන්න පුළුවන් නම් හරි. Right? You are not just watching it. අර නිකන් මේ එකක් බලනවා.
Faster, I give that a bit of gentle heat. So using my tripod and gauze, to open up that Bunsen burner halfway on the air hole and pop this on just for 30 seconds or so. Now, my copper oxide is a solid base, and it's important here just to realise that it's not just alkalis that neutralise acids. A base is any material that will neutralise an acid and form salts. They're not all alkalis, and they can be metal oxides or metal carbonates or metal hydroxides, which we commonly know as alkalis. So that should just be warmed a little bit now. So take that off, it's not too hot, I can't handle it. And I'm going to now add my copper oxide. I'm going to add excess copper oxide, which means I'm going to add more than I need to neutralise all of the acid. That's how will I know you're adding an excess? Well, I'll show you. I'll add a little bit of it to start with, and give it a stir with my glass rod. Straight away, you should be getting a chemical reaction. And if I leave that to settle, we should see that the liquid is starting to turn blue. So all of that copper oxide that I added to my sulfuric acid has now all reacted. It looks like it's dissolved. In fact, it's reacted and it's formed the soluble salt copper sulfate. So I haven't added an excess. I haven't added more than I need. And I need to make sure I do that so that all of my acid is neutralised. So I'm going to add just another spatula to make sure that all of the acid has reacted. Give another little stir, just to make sure that I've made as much copper sulfate as I can. So now I'm sure that I've added an excess because I can see I've got black unreacted copper oxide in my beaker. I need to remove that from the copper sulfate so that my crystals are pure. So we need to use filtering for that because the copper oxide is insoluble. And so I'm just going to take my filter paper, fold it once and then twice into quarters, and then open it up. So I've got 3 thicknesses of paper on one side, one on the other to make a little cone, which I can pop into my funnel. And then I'm going to pour the contents of my beaker into my paper. And we should quickly see the lovely pure blue copper sulfate solution pouring through. There's all my unreacted copper oxide. To put into the filter paper. and we just need to wait for that to filter through now. So we've filtered all the copper oxides out of our mixture, and we can now see we've got our lovely bright blue copper sulfate solution. But the idea of this practical is to get pure dry crystals, and they're certainly not dry at the moment. So we're going to evaporate the water out by pouring the solution into an evaporator basin. And then we're going to have to heat that to get the water out. I could heat it directly over a Bunsen burner, but unfortunately, the copper sulfate crystals do have a tendency to start to break down if you heat them too much, and they release nasty, nasty gases, and we're going to have to evacuate the lab. I don't want to do that. So instead, I'm going to heat them more gently over a beaker of boiling water. So I place my evaporating basin on here, and then my Bunsen burner goes underneath, and this is just a slightly gentler way of heating it. And as the water boils, the steam will heat the bottom of the evaporating basin, and the water from the crystals will evaporate. So we've been...
No, we don't heat it until all the water goes out, right? We heat until crystals occur. We say we reheat until point of crystallization. They are not doing, but we have to do. Therefore, since we don't evaporate all the water, you have a little bit of water remaining in the operating basin after we allow it to cool. That part is not there in this video. That's why, like, you can't learn 100% from the internet resources, because sometimes they are not fully compatible with the syllabus that we do. So after this, we have to filter it again. Yeah. After this, you have to filter this again, right? And then take the crystals and leave it to dry in a desiccator. Is that clear? Understood? That's how you prepare copper sulfate. If you look at your tutorial, workbook, describe how lead sulfate produced. That's question number, part A. There is part C. Describe how zinc sulfate solid is obtained. Then copper sulfate කියන්නේ කවුරු වගේ තමයි? Zinc sulfate වගේම තමයි. Right? You have to write the procedure in words now. But don't worry, I'm not going to put you in trouble. You have this diagram over here. අර තියෙන step sticker, the central part. You have to put zinc oxide, zinc hydroxide, zinc carbonate, anything, doesn't matter. Why? All of them react with sulfuric to give zinc sulfate. Then there are no reactions. Your step one, you're adding excess, any of those, even zinc powder is all right. Yes, sir. Right? So you don't sit there, either sit here or at a corner. Right? And that's the first step. Excess zinc oxide is added little by little to sulfuric acid. Better mention the volume. Right? And you're warming up because sometimes the reaction requires a little bit of heating. And then excess zinc oxide is filtered, right? Taken into a filter paper. That you are going to discard. And you have zinc sulfate solution. And then zinc sulfate solution is subjected to what? Crystallization. What we do in third step? Third step එකේ මොකද කරන්නේ? මොකද කරන්නේ? Evaporating dish එකට දාලා මොකද කරන්නේ? You evaporate all the water? No. You evaporate a lot of water. But you don't get crystals actually. You have to allow it to cool to produce the crystals. Step 4 is what? Allow it to cool to produce more crystals. Once the crystals are obtained, what you have to do in the step 5? You have to filter it again. Right? And step 6, we are going to skip. We are not going to wash the crystals. Instead of that, we are going to what? Dry the crystals in a desiccator or in a, just leave it in a filter paper to dry naturally. Exactly, but desiccator is more, much easier, convenient. can you write those 6 steps? Diagram is there. On the diagram, steps highly under the then yeah. Next day we'll be doing the titration method and then the insoluble salt method. Then the syllabus is done for the monthly test. Yeah, zinc sulfate. Copper sulfate and zinc sulfate. Zinc sulfate is the waiting. Steps take a Sorry? Fill the pen. You have to mention what apparatus being used. Huh? Shall we check the answers? Right. Statement 1. Add excess. Any of those, huh? Zinc oxide, zinc hydroxide, zinc carbonate, zinc powder. ඒක කොහොමද පුතේ decide කරන්නේ? කොහොමද decide කරන්නේ? අපි දැන් ඉගෙන ගන්නනේ reactions with acids. Any of those will react with sulfuric acid. The zinc sulfate හදන්න නම් you need sulfate ions. Zinc from any of those. Right? So you add, you select anything like such as zinc oxide. Add zinc oxide solid little by little to excess warm sulfuric acid until it won't dissolve. Hey, listen, why we put until it won't dissolve? We have to make sure all sulfuric is over, right? Then we don't need that excess thing. So you filter the solution using filter paper, filter panel, and discard the powder. Residue, discard the residue. The best word is residue. Obtain the solution. And then the solution is heated in an evaporating dish, right? Evaporating dish until the word is until the crystallization starts. Until the crystallization starts or until it goes saturated. You have to use these words, okay? Until it goes saturated. Then you allow the solution to cool to form the crystals. Cool and the crystals hadenne. And then filter the solution. Now you don't need the solution. You need your crystals in the filter paper. And those crystals are put into desiccator or dab with the filter papers to go dry. Is that clear? So this is your what? Procedure of what? Preparing a soluble salt. Methods දෙකක් තියෙනවා. එක method එකක් ඔන්නත් කියලා දුන්නා. තව method එකක් තියෙනවා next day කියලා දෙන්න. Is that clear? පාඩම් කරලා එන්න මේක. මම ඊළඟ දවසේ අහන්න. You get it? All right. So with that, I'm going to wrap up the meeting for the day. And by next week, we'll be done with the theory for your monthly test even. Right? And now you can start answering the past paper tutorial. Right. Bye.